All right, here we go. So last class, what did we do last class? Because I know quite a few of you weren't here. Hey, let's do something. Let's go see how many people watched the lecture from Monday. Because we had quite a few people not here, right? Let's see if anybody watched the lecture. Where is it? No, my playlist. Let's see, here we go. Y'all doing okay? Y'all seem a little quiet today. What's going on? Y'all tired? Yeah? Okay. The it's nice outside, isn't it? Sunny? Still too cold, huh? All right. This is taking too long, isn't it? Here we go, moment of truth. Which day is it? Okay, 5 views, only one person, well, it ended there, so maybe 5, that's not bad, okay. Not too upset about that. Well, if you haven't watched it, you're missing out, I'm telling you right now, it's so good. Okay, so last class we were graphing lines using the intercept method, right? And I said there's 2 methods, right? There's 2 methods. And I said, you don't want to get yourself married to one method or the other. You just want to be able to use them both because sometimes it's easier to do one than it is the other. When it comes to graphing, I think the slope-intercept method is pretty nice. So I'm going to start with just kind of reviewing what it is, what the slope-intercept method is. Okay, so the slope-intercept method is all about this. It's all about trying to take your equation. So you start with your equation. And what you want to do is basically solve for y. All right, that's it. That's how the slope-intercept method works. You start with your equation and you try and get y by itself on one side of the equation. If you can do that, then you're guaranteed that your equation will eventually, after you kind of massage it, multiply things through, you might have to clean it up, but eventually you get to this form right here. And this form is a very nice form for a line. I'll give you a specific example next to this. Let's say +2 right there. So here's a specific example of an equation that had x and y in it, right? Like we talked about last time, it had x to the first power, y to the first power. There's an equal sign, so we know the graph of this is a line. But if I solve it for y, it would look like this. And you notice how in front of the x you have a number, right? And then on the back side you have a number right here. So in this particular form, the m is 3 and the b is 2, right? So m, and I know a lot of you already know this, all right? The m is something special. It is what part of the line? What does that number right here represent for the line? The what? No, maybe not. That's the slope of the line. Now, when we talk about slope of a line, we're talking about the pitch of the line, okay? So anytime we have a positive number here, our line's going to go like this. Anytime we have a negative number, our line's going to go like this, all right? If this is 0, if m is 0, this whole piece will be gone, and that means our line is flat, like this, all right? So this is the slope of the line. Now the other number, b, that's an important number also. What is that called? Do y'all know what that is? The b, the 2 over there? The intercept. But remember last class, there's 2 intercepts. There's an x-intercept and a y-intercept. So this 2 is always going to be your y-intercept. Now, why in the world would the b always be your y-intercept? Let's just think about it for a second. To find y-intercepts last class, what did we do? To find the y-intercept, you set x equal to 0, right? So take a look at this general equation. Let's say you can solve it for y. Like say we've got it here, and now I say find me the y-intercept. You would let x be 0, wouldn't you? And if that's 0, this is gone, and what are you left with? B, right? So y equals whatever that number is, that has to be your y-intercept. Because in this form, letting x be 0 will always kill this off. So that number out here will always be your y-intercept. Okay? We together on this so far? Okay, so how do we actually use this information right here to graph the line? So what we do first is we realize that this number 3, we want to always take that slope, whatever it is, and make sure we write it as a fraction. So I'm going to write 3 as 3 over 1. And notice I'm not messing with the x. It's just the number in front. So this right here is the slope line written as a fraction. And this will always represent what we call our rise over our run. Does that sound familiar? Rise over run? Yeah. I'm going to do an example, but this will always be our rise over run. And then this, of course, we said was our y-intercept. So we want to look at this as a point 0, 2. So remember, y-intercept, the x-coordinate is 0. The y-intercept is the number. Okay, so let's use that information to see if we can graph this line. So I'm going to take this right here. I'm going to try and graph it right now. Okay, so where do I start? Always start at the point that you know exists on your line, which is this point. I'm going to start there. So I'm going to go to that point right there, and I'm going to draw a dot. My line must go through that dot. It has to. Everyone agree? All I need is one other point. Once I have another point, I can draw a straight line. So now I use the slope to get me to another point. This says that to get to another point, I have to rise by 3. That means go up 3. And then run is always left and right. And since it's a positive 1, I'm going to move to the right 1. So from this point, not from the origin, not from the beginning, from this point up 1, 2, 3. So up 1, 2, 3, and then over, let's say that's 1. So over 1, and I draw a dot right there. And once I have those 2 dots, whoosh, draw my straight line, and I'm done. Make sense? Yes? Yes? Okay. All right, so we're going to do more of these. But you see that the approach for graphing is completely different than last time. Last time it was, okay, you get the equation, you find the x-intercepts, let y be 0, then you find the y-intercepts, let x be 0. That gives you 2 points. Those points were going to lie like here and here somewhere, or maybe like here and here, or maybe here and here, and then you draw your line. This is different. We start at the y-intercept, and then we use the slope to get us to another point. All right. Yeah, let's just do another one before we bring up the notes. So I'm going to give you this one in the form already. Let's sketch this. Y equals, let's go negative 2x minus 3. All right, so is that in slope-intercept form? Yes? As long as it's solved for y, which it is, and we have a number in front of x and a number by itself, then it is in slope-intercept form. You see why they call it slope-intercept form? Because when you look at it, you can tell me the slope, and you can tell me the y-intercept, right? So let's call it slope-intercept form. All right, so what is the slope? We'll put it right here. What is m for us? Negative 2. We always want to write that as a fraction. So how can I write negative 2 as a fraction? Negative 2 over 1, right? Like that. And so this will be my rise, this will be my run. And then we also need B, which is the y-intercept, right? So B for us is what? -2? No. -3. Okay. Right? Pardon? And so that really represents a point on my graph, and that point will always be 0, and then whatever that number is. And then we go and we graph. So here comes my graph. Starting where? -3 where? On the y-axis, right? So we want to go, starting here, go down 3. So I'm going to go down 3 here. 1, 2, 3. That's -3. I'm going to put a point here. And then from here, I just need to get to another point, so I need to use my slope. But we have to be a little careful here, right? Because we have a negative number on top. And a negative rise would mean not go up, but go down instead, right? So this means I'm going to go down 2, and then a positive 1 on the bottom means I will go to the right 1. Okay? So this negative is on the top and on the top only. It's not on both. So from this point, I'm going to go down 2, so down 1, here's 2, right? And then to the right 1, like this. So 1 unit to the right, 2 units down, 1 unit to the right. Draw a dot, draw a line, and we're done. Any questions? Pretty straightforward? Out of curiosity, could somebody have written this fraction this way instead? Is that the same fraction? Are all 3 of these the same number? We talked about this in the very beginning of this class, that this is all the same. When you have a negative on a fraction, the negative can be on the bottom or on the top. You can slide the negative up or down. You just don't put the negative in both places. So this and this are the same, right? So what if some person here is like, well, I don't want to be like everyone else. I'm going to do it this way. Are they going to get the same line? Well, they would start at the same y-intercept, wouldn't they? And then what would they do? This would tell them to go which way? Up 2, right? And then this would tell them to go which way? Left 1. And so if you go up 2 and left 1, voila, look, you're going to land on the same line. Now your points will be different, but it's the same line. Do you all see that? So it doesn't matter. You can't really mess that up. Is there a question? Okay. Okay, let's see what kind of problems we have here for us. So write each of these in slope-intercept form. Identify the slope and the y-intercept of each. So this is not asking us to graph for these first problems. So how about number 1? This one right here. Is that in slope-intercept form? 2y equals 3x plus 8. Is that in slope-intercept form? No? Why not? Because there's a 2 in front of the y. You need y by itself. So you have to get rid of the 2 in front of y. So what do you do to get rid of a 2 that's being multiplied times y? Divide everything by 2, right? Everything, both sides of the equation. If you like, you could say multiply both sides by 1/2. However you want to look at it. I'm just going to take this equation and I'm going to divide everything by 2. So 2, 2, 2. Here I get y. Here I get 3/2 x. And then plus 4, right? 8 divided by 2 is 4. So what is the slope of this line? 3/2. And then the y-intercept is the 4, which will turn into the point 0.04. Okay, so then we could go graph it, right, if we needed to. All this wanted was the slope and the y-intercept. So there's your slope. You can just write 4 if you want. You can write it as a point, whichever, I don't care. Just make sure when you go to graph, it's a point, right, on your y-axis. Let's take a look at the next one. Okay, negative 3y equals 3x minus 9. Is that in slope-intercept form? It is not, right? Because again, you have a negative 3 in front of the y. So now we're going to divide everything by negative 3. So negative 3 here, negative 3 here, negative 3 here. What do I get on the left side there? I forgot my sticks today. I mean, I'm not prepared. I'm not prepared today. What do I get on the left side? Just y, right? Because negative over negative is positive, so you just get y here. And then, yeah, be careful here. What is this? This is positive 3 divided by negative 3, which is negative 1, right? So I need to put negative x, or I could put negative 1x, whichever one, but I'm going to reduce that fraction. And then this over here, be careful. What is this? Yeah, if you look at these two together, just those two, that's negative 3, isn't it? But you're subtracting negative 3, which really means plus 3. So you just have to pay attention to those signs. Be careful with them. All right, what is the slope of this line? What is the slope of this line? Negative 1. Now, what is that written as a fraction? How can you write negative 1 as a fraction? Negative 1 over 1, right? Which would mean if, what's that question or? Would it just be 1? Negative 1 over negative 1 would be 1, right? But negative 1 over 1 is negative 1. So we have, anytime we have the slope, we have to write it as a fraction in order to do our rise over run. So when we go, if we were going to go graph this, this would tell us we need to go to our y-intercept, wherever that is, and then go what? Down 1, right 1. Okay? Down 1, right 1. But we still need our y-intercept. What was our y-intercept? Well, that's our positive 3, right? So our 3, and then that would give us the 0.03. Let's see here. Let's look at...
Does the run always go to the right?
The run does not always go to the right. It depends on if you have the negative on the top or the bottom. So like if this was if this was positive and this was negative, then your run would go left. Who asked that? I just heard. I didn't. Yeah, so you can write, like I could if I wanted to rewrite that fraction this way, right? That's these. This is the same as this. So then my run would be to the left. Make sense? It's up to you, yeah. It's like the problem I showed you just a second ago. If we do it one way, we went down and over, but if we flip it and do the fraction the other way with the negative on the other side, we went up and to the left. You get the same line either way, yeah. Okay, how about number 3? Is that in slope-intercept form? No, it's not, right? We have 2x plus 3y equals 15. So that is not in slope-intercept form. And so to get into slope-intercept form, first of all, you've got to get all your y's by themselves, right? Any y's by themselves. So I want to try and get this thing right here alone on the left side of the equation. So how can I get the 3y by itself? Take away 2x on both sides. Subtract 2x from both sides of the equation. So subtract 2x here, subtract 2x here. When I do that, these 2x's cancel. I get my 3y on the left. Now on the right side, I cannot put 15 and 2x together, right? They're not like terms. Like that doesn't turn out to be like 13x or something, right? That's just 15 minus 2x. That's what it is. But I'm going to write it another way. I'm going to write it negative 2x, bless you, plus 15, bless you. That's it though, no more. I did that last class, didn't I? No, at the end. I'm gonna kill this thing. Okay, so is it all right that I've written it this way? And I've done it because I'm trying to get it to look like, eventually, y equals mx plus b. So I always want to put my x term up in front. Now, are we at slope-intercept form yet? Nope. We need to do what? Divide everything by 3. Divide by 3, divide by 3, divide by 3. And now, if we start reducing everything out, things should get nice here. On the left side, we have our y. What about this right here? Negative 2 over 3. You can't do anything with that, right? So I'm just going to leave it as negative 2 over 3 times x. So that's the number that's sitting in front of x. And then this one, fortunately for us, is a nice integer, a nice whole number. 15 divided by 3 is 5. So now we have our slope-intercept form. Y equals mx plus b. And m here is negative 2 over 3, right? So the negative is on the top, the positive is on bottom. So this means we would go down 2, right 3, right? And then our y-intercept, which comes from the b, is 5. So that corresponds to the 0.05. Okay, questions? I want us to consider a real-life problem. Now, I'm going to ask, because I know some of you might work, I'm going to ask you something. I'm not going to be asking you how much money you make or anything like that, all right? I'm just going to ask, does anybody here work on commission? Anyone here work on commission? Do you all know what that is? Commission is like, think of someone who sells cars. Okay, they make a certain amount of money for just coming in and working, but every car they sell, they make more money. Okay? That would be a commission. So they get like a base pay, plus they get so much per vehicle they sell. That would be commission. So imagine that, I'm just going to totally make this up, all right? Let's say that you have an employee, or let's say you're talking about you. You make, I'm completely making these numbers up, okay? You make, let's say, $4,000 a month. All right? $4,000 a month as a flat, just, that's what you get for showing up, doing your 40 hours a week or whatever it is, all right? Okay? You make $4,000 a month plus 3% of your sales. Now, I don't know what we're selling. What are we selling? I don't know. Who cares, right? We're selling something. Cell phones, laptops out the back of our car, whatever it is you're selling, right? So you make $4,000 a month just for showing up and trying to sell stuff, and then you make 3% of your sales. I don't know. Let's just make it easy. Let's just say we're selling TVs, all right? And I mean, okay, we're selling TVs. So we work at Best Buy or something. I don't know. So can we come up with an equation that represents our monthly pay? Find an equation which gives your monthly pay. So as long as you show up to work and are being productive, you're making $4,000 a month, right? Just breathing. But you're also going to make a little bit more for every TV you sell. So 3% of each TV, right, you're going to make money on? All right. Well, how do we do this?
Y equals 3 over 100x.
So you're already trying to make like a line out of this, an equation? Okay, but I'm going to get to that. I'm going to get to that. What I want to use, let's use some variables that would correspond to this. How about we use P for pay? That's your pay, all right? So what is our pay going to be? Our pay is going to be, no matter what, $4,000, right? But that's not it. It's plus 3% of our sales, right? So how about we write 3% as a decimal, because that's the way what we've always done in math. We always convert this to a decimal. So isn't that 0.03, and then times however much we sell, right? So why don't we call that S? That makes sense? So capital S, whatever. It doesn't matter what you use. Does everyone see that this is a line? This is a linear equation. This looks like y equals mx plus b. We have y is really like the p, right? The 4,000 is really like the what? The b. The 0.03 is m, and the s is really the x. See, this is a linear equation. This is a graph of a line. So if we graph this, if we graph it like we graphed that, then what we would get is a visual representation of our monthly pay based upon our sales. With me? Okay, so I'm going to try and graph that now. And try and squeeze it in right here. All right, so if I squeeze this in right here, S is my sales, P is my pay. So just like X and Y, it's now what? S and P. Understand? So where do I start to graph this thing? 4,000, right? On the y-axis, go up. I'm going to make $4,000 no matter what. Like if my sales are 0, I'm making $4,000. Now I need another point, don't I? So how do I get to another point? How do I get to another point on that line? What do I use?
You have to change 0.03 to a fraction.
Okay, so we're going to use this as our slope, right? M equals 0.03. Now we have not dealt with this before. We have not had a decimal and then had to convert it over to a fraction. So does anybody know how we can convert that to a fraction? No? How do you convert decimals to fractions? Okay, so you have to understand what decimals mean, all right? So real quick, when you say 0.2, this means 2 out of 10. If I say 0.5, that means 5 out of 10. If I say 0.3, it means 3 out of 10. If I say 0.21, that means 21 out of 100. If I say 0.54, this means 54 out of 100. If I say 0.215, this means 215 out of what? What do you think? 1,000. And so these, however many digits you have here is basically how many zeros you have on the bottom here. So if I have 3 decimal places, this becomes 3 zeros with a 1, so that's 1,000. If I have 2 decimal places, it's 2 zeros with a 1, so it's 100. If I have 1 decimal place, it's 1 0 with a 1, so it's 10. So this is like your tenths place, tenths, hundredths, thousands. With me? Okay, so now on this, written as a fraction, this is what? 3 over 2 decimal places, so 2 zeros, 3 over 100.
On tests, do you care if they're reduced or not?
Reduced, oh, this right here?
Yeah.
No. No.
It's the same thing.
It's the same thing. I mean, this one won't reduce, but like, yes, this one up here, these would. All right, you okay with that? So that means to get to another point on this line, I have to do what? Go up 3, right? So up 3, 1, 2, 3. Where would that put me? 4,003, right? That's where I'd be. And then over how much? 100. So on this scale here, I can make up my own scale. This is dollars here, dollars, dollars. So what I'm getting at is when you do an X and a Y axes, if this is 4,000 this direction, you do not have to do the same 4,000 this direction. Okay, but if you do 4,000 here, then the other way, that has to stay like negative 4,000. You can't change the scale here. But this scale and this scale can be different. Does that make sense? Okay, so I went up 3, 1, 2, 3, and over 100, which puts me there. And then I draw a line, right? Now, am I going to draw my line back here? Think about that. Should I draw my line? Should I draw my line over there?
Unless you don't want to make money.
Yeah, that would mean if I drew my line back here, then that means my sales would have to be what? Negative. So you're losing the money, the company money, just by going in. Good job. Yeah, so it doesn't make sense to have negative sales. Y'all see that? So this line, right, would represent your pay, your potential pay. So you can kind of see from this, you know, like if you did this on a nice graph, you could actually try and figure out, you know, like, well, how much do my sales need to be if I want to make my pay a certain amount? But I'm trying to tie in a real world sort of situation to a line. Another line is, does anyone here pay for their electricity? If you pay an electric bill, you have a flat fee. Okay, you have a flat fee, and then you get charged by how many kilowatt hours you use. So the more electricity you use, the more you pay, right? So when you look at your bill from like CPS or whatever, this right here is what we call our fixed cost. Okay, that's how much you have to pay every month, even if you shut your electricity off and you turn everything off in your house. You still have to pay to have the electricity available to you, all right? It's a flat fee. Everyone pays it. And then you pay a certain amount. Okay, this is like a rate that you pay. And then this is the amount you use, amount of electricity. Whatever, electricity. So as your electricity as you use more, right, you multiply by the rate, and then this is going to be an added cost. So this is like, the salesman makes more money the more he sells, but on the other end, your electric bill, you pay more depending on how much you use. And actually, this is a lie, because the way the electricity works is that you pay a certain rate up to a certain amount. And then if you use more electricity, they charge you a different rate. So like if you're one of these people who have like a 5,000 square foot house and you've got like a pool and all this crap running and you're using a lot of electricity, you pay more per kilowatt hour than a person who's just in an apartment does, because they don't use as much. Water's the same way. If you're in an apartment, you just use a little bit of water, your rate's real low. If you've got a 2-acre estate and you've got irrigation systems and you're watering your grass all the time, then you will pay an enormous amount more. It's like quadruple the amount, because I guess you're wasting water. I don't know, whatever. Okay, so I'm kind of lying. With electricity and water, this is actually a little more complicated, but the basic idea is still the same. It's linear. The joys of the real world. Okay, let's go back to our notes. Let's see what they're wanting us to do here. All right, so for all of these, it's the same story. I think we should mess with a couple of these. How about this one right here? How about negative 3y equals 12? Ooh. Put that in slope-intercept form. Is that in slope-intercept form right there? No, because it's not y equals mx plus b. So what do we do first? Divide both sides by -3. And this one's weird. Do y'all see it's weird? You get -4, right? So you don't have an x in there. You don't have x. In last class, we talked about this. This is a horizontal line. This is a horizontal line that goes through y equals -4. So it's like, here's your x-axis. Move down 1, 2, 3, 4. Draw a horizontal line. There it is. But that is in slope-intercept form. This is actually, it's hard to see it, but this is actually y equals 0x minus 4. Do y'all agree that there's a 0x right here? I mean, it's hidden, but it's there. And so you could argue with me right now that the slope of this line is 0, which it is because horizontal lines have a slope of 0. Now what about 6? 6 is special. There is no slope-intercept form. Because for slope-intercept form, you must have y equals, right? And if y doesn't appear in the equation, then you can't possibly put it in the slope-intercept form, right? So, but what kind of line is this from last class? This is a vertical line. How would I solve for x there? Divide by half, or I could also multiply by 2, right? That would do the same thing. 2's would cancel. We get 16. That's a horizontal, that is a vertical line, isn't it? So this is something you should be aware of. When it comes to vertical lines, you cannot write vertical lines in slope-intercept form. It's impossible. There's no way to put this as y equals mx plus b. I think number 8 looks pretty good. Let's do this. Let's do a group quiz. Yes. See, it's worth it for you to be here today. I would like you to work together on numbers 7 and number 8. And I want to give you about 10 minutes to put both of those lines in slope-intercept form and graph each one. Sound fun? I know, it's fun. Everyone's turning in their own piece of paper, all right? But you can work together. So don't write it on your notes. Get a fresh piece of paper, and I want to see all the steps. Do you understand the instructions?
Yes.
You have to graph it also. So you have 2 lines to graph here, and I gave you the hardest ones because they have fractions in them. So enjoy. And if you're one of those people who don't like working with people, that's fine. Okay? You can just work on your own. But you're free to help each other out.